today's lecture, we're going to go over solving simple equations. So right here we have x minus 7 equals to 12. When it says solving equations, it means that you wanted to find out what x is going to be in order to make this left side is equals to 12. So something like this simple, maybe you can think about, okay, what number you need to subtract 7 to become 12. That will be 19, right? That's something you can do, but that can't happen when this is simple like this, right? What about if we go this far? That's something that we cannot do that on our head. So we have little steps that we wanted to remember. So again, when it says solve the equations, then you wanted to solve for a known variable. You wanted to know what this x is. In order to do that, we're going to isolate this on one side. So variable one side and move everything else to other side is basically what we're going to do. In order to isolate x, you need to get rid of minus 7. If you wanted to make x by itself, get rid of negative 7. So that means you need to add 7. In equations, whatever you do on one side, you want it to do exactly the same thing on the other side. So when you're getting rid of the 7, you're adding 7 to 12, so you end up getting 19. Let's look at the other one. So again, we wanted to solve for x. And x plus 9 equals to 3. What x can be, right? So don't think about it. Remember what I mentioned. You wanted to solve for x. You wanted to isolate x. It means you need to get rid of plus 9, right? So you wanted to subtract 9. You're doing opposite when you're trying to get rid of whatever that is attached to variable, right? So this will cancel out. Your x is equals to, remember we went over adding, subtracting. If you have different sign, you're subtracting bigger number minus smaller number. So 9 minus 3 is 6. And get the sign from the bigger number. So it will be negative 6. Let's look at the next one. What about if we have x over 2 equals 7? You wanted to isolate x. That's what I've been saying. So in order to isolate x, you wanted to get rid of dividing by 2, right? So how do we get rid of division 2? By multiplying 2, right? You need to do exactly the same thing on other side. So 2 being 2 over 1, this 2 cancels out. So it gives you 1 and 1. In other words, 1 times x is x. 1 times 1 on denominator is 1, where you don't really need to write that down, right? And then 2 times 7 is 14. The next one, we have negative 2x equals to 14. Again, when we say solve for x, you're going to isolate x by itself. It means you wanted to get rid of these multiplications. So in order to get rid of multiplication, you're dividing by negative 2. Again, you need to do exactly the same thing on the other side. Negative 2 over negative 2, that's equals to 1. So that's going to be 1x. And then 14 divided by 2 is 7. And you have 1 negative, so it will be negative 7. As you can see from this 4 problem we just did, if you're going to try to get rid of negative 7 that is attached to a variable x, then you're going to add. If it's addition 9, you're going to subtract. If it's divisions, you're going to multiply. If it's multiplications, you're going to divide. So in order to isolate the variable, you do opposite of what it's doing it to the variable itself. Okay, let's look at the next one. It's getting a little longer and longer, and you can see this one, we have two variable x. So what I need to do is first, I wanted to combine them together. You wanted to put it all one side, so I can make it 1x. So what I need to do is put all the x together, and let's say if I can move this x to other side of equal sign. And when I'm moving x to other side of equal sign, it changes sign into opposite. So it was positive x, you had 2x before, moving into other side of equal sign become negative x. Don't forget, positive x become negative x when you move to other side of equations. And then you had 1 before, and you wanted to do the same thing with negative 3 because you wanted to put number with the variable one side, number without the variable on the other side. So negative 3 become positive 3 on other side. Once you put it all together with the same term, you can combine them to make it 1, right? So 2 minus 1 is 1x. 1 plus 3 is 4. And of course, all this problem that you're just solving, you should be able to check your solutions when you replace it. I'm going to show you on this one. If you wanted to check, you just need to replace the 4 that you just found into the given problem. So it will be 4 times 4 minus 3 should be equals to 1 plus 4. Isn't that 5? Yeah. So let's see if I get 5 on the left side. That's going to be 2 times 4 is 8 minus 3 is 5. Yes. So we can always check our solution when you're solving equations. Let's look at the next one. Again, look like I have negative 3x on the left side, positive 4x on the other side. So if we wanted to put number with the variable on the left side and number without the variable on the right side, let's start moving around a few number. So I will start with negative 3x, and then when you're moving positive 4x, it will become negative 4x. I had 3 before, and I'm moving positive 16 to the other side, so it becomes negative 16. Combine the like term, I get negative 3 minus 4, which is negative 7x. This gives you negative 13. And when you're dividing, you wanted to isolate x, right? So you wanted to isolate x, and you have multiplication of negative 7. So you need to divide both sides by negative 7 to isolate x. Then you get x equal negative is positive, and 13 over 7. And don't forget that cancel out and become 1, right? Let's look at one more. What about if we have parentheses? So you cannot combine or move over to other side of equations if you have a parentheses. So first thing you wanted to do is opening the parentheses. So look like you're going to do distributions, right? So 3 times 2, 3 times negative 3 equal to x minus 9. Once you have nothing to block the values to moving over to other side, then now you can put number with the variable together. So let's put it on the left side. I had negative 9x before, positive 2x from other side become negative 2x. You had negative 9 before, positive 6 from other side become negative 6. Combine the like term, that's negative 11x equal negative 9 negative 6 is negative 15. And again, in order to isolate x, you need to do opposite of what negative 11 is doing it to x, which is multiplications. So I will do the divisions. Dividing both sides by negative 11, then I get x equal negative negative positive 15 over 11. These two examples I wanted to do. All other problem we had one solutions, right? But not always you have one solution. That's what I wanted to show you. So let's see. We don't know what until we solve the problem. So this problem H, I see the parentheses, so I wanted to get rid of that first, right? So on the left side stays same, the right side you do the distributions. And you can see that you have right side, which is 2x plus 2 is equals to the right side, 2x plus 2. They're equals to each other. In this case, no matter what x I'm going to have, it will be always matching right and left, right? So this one, you're going to have many solutions, okay? But let's say you didn't realize you have the same thing, and what you need to do next is put the number with the variable together and number without the variable together, right? And this gives you 0, and the other side is also 0. So here, whenever you cancel out your variable, so no longer you have a variable, like this one right here, this 2 cancel out each other, make it 0, right? So there is no more variable. And if this equal sign right here holds the true statement, we know that 0 is equals to 0, right? If this is true statement, then your solution is going to be always many solutions. Many solutions. If you wanted to write that many solution into the interval notations, you could say negative infinity to positive infinities. So all real numbers. And that's another notations, right? All real numbers. So when do we have all real number? When the variable disappear and your equal sign is holding a true statement. Let's look at the other one. What about this one? So we're going to put number with the variable together, number without the variable together. Again, your x disappear, your variable disappear, and you get 1. Where this time you have false statements. 0 is not equals to 1, right? So when the variable disappear and equal sign is holding a false statement, your solution is going to be no solutions. So x, no matter what value you're going to, oh wait, hold on, I'm missing s right there. And no matter what value you're going to replace it in this equation, you're not going to be able to have equal from left to right, right? So that's empty signs, or that's another empty sign. So no solutions. Again, when do we have no solutions? When variable disappear and equal sign is holding false statements. When equal sign is holding true statements, you have many solutions. Second example we have in this section, we wanted to see if we can change into equations from the given statements. So let's look at the one example A. A number decreased by 7 equals 12. So before, remember, I wanted to find equal sign first. So here I see equals. Something equals 12, right? So I found one side. What's the other side saying? Number decreased by 7. When it say decreasing, this is same thing as negative. And we know we have 7 there, right? Number. That's the number that we don't know. So we can use the variable x maybe, right? So what it's saying in this statement is x minus 7 equal 12. So we wanted to get used to writing the statement into the equations. Let's look at another one. A number divided by 2 equals 7. Again, where's the equal sign? Right here. So I found the equal sign, and it said that's equals to 7. So I found the right side. Let's look at the other side, left side. Number divide by 2. So again, what I have in this problem is x divided by 2 is equals to 7. That's not bad, right? Let's look at another one, this 2. I have 3 less than twice a number equals 1 more than the number. Again, where is equal? Right here. So I have equal sign. So from in front of equal sign, that's going to be on my left side. Behind equal sign, that's going to be my right side. And 1 more than the number. So 1 more than the number, how are you going to write that? 1 more than the number. You will say x plus 1, right? And let's see what else I have on the other side, right? 3 less than twice the number. 3 less than twice the number. What's the twice the number? Twice the number is going to be 2 times x. Right? And 3 less than that number, you can write it as 2x minus 3. We had equal sign and x plus 1. Once you write it into the number equations, right? All these 3 problems that we just did, once we write down into the equations, we should know how to solve it from the other example 1 we did, right? Right now I'm doing an exercise of how to change from the statement to number equations. But once you change the equation, you should know how to solve. Let's look at the D. It's a half a number equals. So my equal comes early this time. So let's see, draw the line. Half a number. So you wanted to show that. How do you show half of the number? So number is going to be x. Half of that, you could do divide by 2, right? Half of 1 is 1/2, right? So same thing. Equal. What's the other side? Twice the difference of the number and 12. Difference of the number and 12. Difference of number and 12, they're talking about subtraction. Difference is going to be subtractions, right? And it's a twice the number of, so twice of this. How do you write twice of that? It's going to be 2 times x minus 12. And then I'm going to show you this one, how to solve. So we're going to open the parenthesis. And then put the number with the variable together. So I had x over 2 and then minus 2x equal 24. Well, 24 was negative, right? and then combine the like terms. So in order to do subtraction, you need to have a same denominator. So on the left side, in order to have same denominator, this is going to change to 4 over 2, right? 2 is same as 2 over 1. If you wanted to change to have denominator 2, you're going to multiply numerator by 2, denominator by 2, which gives you 4 over 2, right? So that's going to be now. And if you wanted to rewrite this so that you know what number you're going to add, this x, you can rewrite it as 1 over 2x, right? That will be the same thing. So you're basically doing 1 over 2 minus 4 over 2. That gives you negative 3 over 2x. And then, in order to isolate x, you're doing opposite, right? So what's opposite? Right now, you have multiplications. So you're going to divide this by negative 3 over 2. But if you do that, let me show you what happened when I do that. This is going to become complex fractions, where we didn't talk about it in this class yet. So instead of doing that, we're going to do each one opposite. So let me erase that because that's faster or easier. So now I'm going to multiply. So instead of dividing by 2, I'm going to multiply 2. Instead of multiplying by 3, I'm going to divide by 3. And I need to multiply negative to get rid of negative, right? So I can isolate x by itself. It means I need to do exactly the same thing. Multiply by 2/3. See where I got that number from? So opposite. So you flip these fractions. This 2 is divided, right? 2 is divided, so you multiply it. 3 is multiplied to x. Now you divide it, right? So you're doing opposite of each one instead of the whole thing where you're going to see the complex fractions. So if you do that, you can see that 2 and 2 cancel out, 3 and 3 cancel out, negative cancel out. You're going to only have x on the left side. On the other side, you're going to have negative, which is positive. And then you're going to have multiply 2 times 24. So it will be 48 over 3. And when you divide 48 by 3, you know you're going to get 16.